Thanks again for joining in. The session for today is on maths, functional skills, maths at level 2, and we're looking at working with fractions. Lots of people say they don't like fractions, and I can understand that. It's one of those terms when people say, "Oh no, we're doing maths." Oh no, are the fractions? It's one of those things that people don't particularly like. But fractions are quite a common thing in maths. They're certainly a common thing in functional skills. So we're going to go through some of the things working with them today. There's quite a lot of different aspects to working with fractions. So I'm not going to cover everything today. I'm going to mention what fractions are, talk about what these things called improper fractions, that will lead on to talking about simplifying fractions. In terms of that process, you can then compare, add, subtract, and multiply fractions that we'll look at. And then finally, we'll finish with how you find a fraction of an amount. And it should take about half an hour. We'll see how we go, but hopefully about half an hour, and stay around for questions or anything at the end. One thing I will say is I've mentioned already, fractions is a big component of maths, and people do get worried about it. So some of the stuff I'm going to go through is quite basic. So if you're sitting there thinking that's really obvious, please don't think I'm trying to patronize you or anything like that. It's about just making sure everybody understands where we're at. Similarly, at the other end, if I do go too quick and you're not sure of something, please do stop me. Or, as I say, if you want some time to think about it and think I need to consider what I've said there, just let me know, and then you can contact myself or Eamon afterwards to answer questions. So hopefully there'll be some part in it. Some bits in it might be too easy for you, some bits might be too hard, but hopefully it will generally be about right of the things I'm going to cover. So fractions are everywhere. There's fractions in everything we do, and say certainly in functional skills you'll see lots of things about fractions, and we do use them every day, even though you probably think you don't. So a fraction, it looks like that. It's one number and then usually a line over another number. In this case, this is 1/4. The makeup of a fraction is in two parts. The top part is called the numerator, and this tells you how many parts you're dealing with. And the bottom number is called the denominator, and that's how many parts there are in total for the whole thing. Not too important if you remember the word numerator and denominator, but it's no harm if you do. It's an extra thing to add, so I will be referring to them before. But numerator is the top number, denominator is the bottom number. So when we see that, it means 1/4. So there's 4 things we could have, and we've got one of them that's saying there. Obviously, with this one, we'd also call it a quarter, and some have other names like that. But we're talking about one part out of a total of 4 parts. Good way to look at things. If you look in maths, everything to do with maths is usually to do with pizza. It always comes back to pizza. So if we think of a pizza as our whole pizza, we've got one pizza. And as you can see there, we can cut it into 3. So we've got 3 pieces, and each one of them is one piece. So you've got 1/3, also known as a third, 3 times. So 3 is the whole thing. The whole thing is made up of 3 bits. We've cut them, and each one is worth 1 bit. So if we eat one of those pizzas, one of those pieces of pizza, we're left with 2/3, which is 2 bits left out of the total of 3. So as the fraction we would call that is 2/3, 2/3. And again, hopefully that's fairly straightforward, but just maybe explains what the numbers are and what they're there for. The first thing I said I'll mention, I was actually going to do this a bit later, but I think it's useful now because we may come across it again, is this thing called improper fractions. So if I go back here, 1/3, 1/3, or 2/3, or the previous slide was 1/4. Normally, our fractions have a lower number on the top than they do on the bottom, because the bottom is the total. So if this pizza's out of 3, so we've got to have less than 3 to be the number of parts of it, 1/3 or 2/3. If we've got 3/3, that's the whole pizza. But you can have what are called improper fractions, and they simply mean that you've got a bigger number on the top than you have on the bottom. But we wouldn't normally leave a proper fraction like that. We wouldn't normally use that as the number. If we think about what this is saying is out of a total of 3 bits, we've got 8 bits in total. So what that actually means is we've got 3 bits on that pizza, we've got another 3 bits to make 6 on that pizza, and we've got another 2. So in total, we've got 8 bits of our pizza. So we actually have 2 full pizzas and 2/3 of our third pizza. So instead of the improper fraction of 8/3, we would normally write that as 2 and 2/3. We've got 2 whole things and 2/3. Technically, they're both correct. It is 8/3, but it's called an improper fraction, which suggests to you is it's not proper. It's not something we should do. So we would normally write that as 2/3. So one functional skills question you might just get might be simply to say, write this improper fraction as a normal fraction. And it would simply be say, well, I can see that it's out of 3, and I've got 3 makes 1, 6 makes 2, and then I've got 2/3 left over. So that gives me 2/3. Similar thing, but sort of working the other way is what's called simplifying fractions. What we also always want to do when we're working with fractions is to give answers in their simplest form. and you'll see why in a little bit. It helps us better understand them, and so you'll see why in a little while. So I'm going to use an example for this and talk through, and I'll go to the whiteboard and talk through it. So let's think of a school. The school has a total of 300 children, and 180 of those children in that school are girls. And we want to know what is a fraction of the number of girls in the school. So as a fraction, it's 180 out of 300. Our total is 300, which is our bottom number, our denominator. And our numerator, our top number, is how many we've got. And in this case, we've got 180 out of 300. So we will write the fraction such as that, 180 over 300. Just going to go now to my whiteboard. I'll show you. So if I put that on again, and hopefully this is all showing on your screen. If it's not, please send me a message or shout or phone me or something like that. So we have a fraction of 180 out of 300, which is correct. That is the correct fraction. There's 180 girls in this school out of a total of 300. But as I say, we want to do this thing called simplifying fractions. And what simplifying fractions does is it takes the fraction down to the lowest possible numbers. Again, we'll work through an example. To do that, we want to have a look at whether there's any numbers that go into the numbers that we've got on the screen. The rule is going to be whatever we do to the top number, we have to do to the bottom number. So we couldn't suddenly half the top number and leave it 300. We couldn't suddenly say there's 90 girls out of 300 because that would just be wrong. So if we're reducing the number of people in the top number, we have to use bottom number. Lots of ways you can do this. The first thing for this example I would look is both of these, both of these end in a 0, which means they're multiples of 10. So what we can actually do first of all is divide both of them by 10, which would give us 18 over 30. I could have done that on a calculator, but they both ended with 0. So basically what I've just done is crossed out the 0 at the end. So my original fraction was 180 out of 300. I've now reduced that down to 18 over 30. If I now look again, both of these numbers are even numbers, so I know I can divide them by 2. 18 and 30 are both even numbers. So if I divide them again, I've now got a fraction of 9 over 15. So I'll divide the top number by 2 and the bottom number by 2. 18 divided by 2 is 9. 30 divided by 2 is 15. I can actually find another number that goes into both of those numbers nice and neatly. Now 2 doesn't, because you can't divide 9 by 2, and 2 doesn't go into 15 either. But 3 does. So if I divided both of these by 3, there are 3 3s in 9, and there are 5 3s in 15. So 3 out of 15 is my fraction. So I started with a big fraction of 180 divided by 300, and I've ended with a fraction of 3 divided by 5. They are actually the same fraction. And if I can go to the calculator, I'll show you. Hopefully you can see my calculator on the screen there. If I do 180 divided by 300, gives me the answer of 0.6. If I do the fraction of 3 divided by 5, it gives me the same answer, 0.6. So the fraction is exactly the same. The formula I'm using, whatever you want to call it, is exactly the same. But instead of writing this big number, 180 over 300, I've simplified down to 3 over 5. I can prove that, I've got it on the screen, so it must be true. We can't go any lower than 3 over 5. There's nothing else that goes into 3 and 5 neatly. 1 does, but obviously there's 3 ones in 3 and 5 ones in 5, so we just write the same number over again. 2 doesn't go into both of them, 3 doesn't go into both of them, and we obviously can't go any higher. So the simplest fraction for that school is 3 out of 5. The reason it's better to use 3 out of 5 rather than 180 out of 300 is simply, if you imagine a school, if you said there's a school here with 300 kids and 180 are girls, imagining how many that is, that's a massive number. If you say out of every 5 children, there are 3 girls, you can see you can visualize that it's just over half the number of kids are girls. So it's half and a bit, and so there's actually less than half of boys. So it's easier to talk about. Whenever we're working with fractions, we should always try and give our final answer as the simplest possible number. So although 180 over 300 isn't wrong, it isn't the answer you would normally give in fractions. You'll see in the functional skills test, it will usually say, give your answer as a fraction in its simplest form, or as the simplest fraction. But even if it doesn't say that, it's good practice, it's correct practice to always reduce your number down as much as you can. Another example of this then, if we're looking at a petrol tank, and you might say, how full is this petrol tank? Well, the first thing we need to think of is the petrol tank goes from 0 up to 8. So the first line is 0, it's not going to be 1 because obviously it's base, and it goes and there's 8 different numbers all around there. Instinctively, we'd say, well, it's on 2, so it's 2 out of 8, which is correct. But we can divide both 2 and 8 by the number 2. So there are 1 2 in 2, and there are 4 2s in 8. So 2 over 8, if we halve them both, is exactly the same as 1 over 4. So actually, rather than saying we've got 2/8 of a petrol tank, we'd actually say we'd have 1/4 of a petrol tank. It's not always possible. Some easy examples there, but it's not always possible to go down to a very small number. So if you had a workplace that has got 104 employees, and out of those 103 are men, first of all, other than not being a diverse workplace, those numbers can't reduce. There's no number, I can promise you, that goes into 103 and 104. So we can't simplify that down anymore. So it's not as niche as saying 2/5 or 1/4 or 3/7 or something like that, but that's the lowest we can go. So if you do need to give a fraction and it needs to be in the high numbers such as that, that's absolutely fine. It's not wrong as long as it can't go any lower, but you always want to try and reduce as much as you can. Hoping that made some sense. And say what I forgot to say at the start is I'll send some questions out after this with all the different types of examples that I've given to practice it. But what we talked about there is simplifying fractions. And as I say, you will usually find a question will ask you to simplify a fraction, but even if it doesn't, you should still always simplify down to the lowest number. The other key learning point is whatever you do to the top line, you have to do to the bottom line. So you can't halve the top one and divide the bottom line by 3. They must be the same. So another thing we need to look at is comparing fractions. So let's take it again. We'll go an example and we'll try and work through it. So if Rafi has a pizza and he cuts it into 3 pieces and he eats 2 of them, but Zara's got a pizza, she cuts hers into 6 pieces and she eats 5 of them. Question there is who ate the most pizza? Well, it's hard to tell straight away. You can probably guess this one, but it's hard to tell straight away because Rafi's only eaten 2 pieces, but then his were bigger pieces. Zara's eaten more pieces, 5 of them, but hers are smaller pieces because she cut them into 6. So it's hard directly, instantly, we can't look and say, we'll compare them. If they both cut them into 3 and Rafi had eaten 2 and Zara eaten 1, you'd say, well, Rafi's eaten more, but we can't directly compare both of them. So we need to do a little bit of maths. So again, whiteboard. So we had Rafi had eaten 2 out of 3, which we write as a fraction 2 out of 3. And we want to compare that to Zara, who had eaten 5 pieces out of a total of 6. So that's what we're comparing. And at the moment, we're comparing thirds with 6, and we can't do that. So what we want to try and do is find some way that we can compare them. Well, there's an obvious thing here in that Rafi's was cut into 3 pieces. But let's imagine Rafi had cut into 6 pieces. And to do that, what we need to do is we need to double what he's done here. So if we double that to 6 over 6, we need to remember what I said before, whatever you do to the bottom line, you have to do to the top line. So we'll double the 2 to 4. Obviously, we don't need to change ours because hers was already out of 6. So now we compare them. Rather than saying 2/3 versus 5/6, we've now got Rafi's has eaten 4 out of 6, or the equivalent of 4 out of 6, whereas Zara has eaten 5 out of 6. So we can see straight away, very easily there, that Zara has eaten more. They're both now, if they'd cut their piece into 6, Rafi would have eaten 4 of his pieces. Zara would have eaten 5 of her pieces, so she's eaten a lot more. So that's probably a fairly straightforward example, but you'll see this a lot where you're asked to compare fractions. So again, rather than giving a scenario of pizza, I'm just going to give you a pure math question. I want to know is 9 out of 12 or is 6 out of 8 more? Which one's higher than the other? And I won't necessarily ask you to respond, but have a think just for a second of which of those you think is higher than the other. And if you think about it, halfway of 12 would be 6. So 9 at 12 is over halfway. Half of 8 is 4. So 6/8 is over halfway. So they're both a bit over halfway. So it's hard to know exactly where they are. We now, though, we need to find a number that we can increase both of these two. Now, 12 and 8 don't go together particularly well. We can't reduce 12 down to 6, for example. We can't keep halving it because we've got an odd number on top and even on the bottom. One thing I can do, and this is just from looking at it, I know that both of those go into 24. So what I want to do is I want to try and make both my calculations so they're out of or over 24. So to make 12 over 24, we simply double it. So all I'm going to do is I've doubled 12, so I'm going to double 9. So 9 over 12 is the same as 18 over 24. 8, 16, 24. So I need to times 8 by 3 to get to 24. So again, whatever we do to the bottom, we do to the top. Times 8 by 3, so I'm going to times 6 by 3. I've now got 12 over 24. No, I haven't. I've got 18 over 24. I'd do my maths right a bit better, wouldn't it? So there you go. So 6 times 3 is 18. So actually, both of those fractions are exactly the same. They're both the equivalent of 18 over 24. 9 out of 12, I've increased to 18 over 24, and 6 over 8. I increased to 18 over 24. So actually there was no difference between them. So whatever they were, pizza or money or whatever it might be, they're exactly the same. But to be able to compare them, I needed to have them both over the same denominator, the bottom number. And to do that, what I've done is I've multiplied that one by 2, and I multiplied this one by 3. And because I've done the same to the bottom as I've done to the top on each occasion, then it's the same ratio, the same fraction, the same relationship between that fraction. Yeah. So whenever you have to compare fractions, the key is you need to get the same denominator, the same bottom number. Which leads very nicely on to adding or subtracting fractions. And this is something that's in the newer version of functional skills, not necessarily the older version. If you're not sure what you do, I can speak to you afterwards. But you may still find it, certainly in the newer functional skills, you will definitely get questions about adding and multiplying fractions. So I'm going to go through both of those. So there's a bit of a description on the screen, but I've only put that there so that when you have the presentation afterwards, it will make sense. But I'm going to go straight to an example for this one. Oops, there we go. So in this example, I'm rather than giving a scenario to it, I'm just going to give a pure maths question. I want 2/3 add 4/9. Now, if we think about what that means, in the first fraction, we've got something out of 3, and we've got 2 bits of it. In the second number, we've got 9 bits, and we've got 4 of those bits. So we can't compare them. Again, if we think about pizza, we're comparing one that's cut into 3 and one that's cut into 9. We can't just simply add them. We can't simply add the numbers 2 add 4 and 3 add 9 because, again, it's out of 3 and out of 9 isn't 3 total, 9 total. That's how many we've got out of them. So what we need to find is this thing called a common denominator that you may have heard or brings back some bad memories from school or something like that. Basically, what common denominator means is the bottom number has to be the same, which is exactly what we just did when we were doing comparing fractions. So again, if we look at this one, there's a fairly obvious one here. This one is out of 9. Well, let's make this one out of 9 as well. So to get 4 out of 9, obviously stays as it is. To get from this calculation at the top to the bottom, we're simply multiplying by 3. 3 times 3 is 9. So we'll do 2 times 3, which is 6. We've now got out of 9, 6 of them, out of 9, add 4 of them. So actually we can add them together. So we've got 6 and 4 makes 10. It's still out of 9 pieces because our number of pieces hasn't changed. Again, if we think of one pizza we've eaten 6 pieces of, and another pizza we've eaten 4 pieces of, the pizzas are still out of 9 pieces, so the bottom doesn't change, our common denominator, but the top does change. If you think back to one of the things we said earlier, we've now got the top number higher than the bottom number, so we've got 10 out of 9. Well, if we think about that, well, 9 of those makes a whole, and that leaves us with 1/9 afterwards as well. So what we've done here is we found what's called a common denominator. So we've got number 9 over number 9 at the bottom of each of the calculations. This one didn't need to change because we'd already got that, so that was nice. This side, on the left-hand side, we've had to multiply by 3. There we go. On the left-hand side, we've multiplied by 3, which gives us 6 over 9. And we've added those together, which gives us 10 over 9, also known as 1 and a 9th. Another quick example to go through. Big numbers here, but doesn't really matter what the numbers are. If we have 14 over 15 minus 7 over 30. And again, I've not got a scenario for this, just give you those numbers. Well, again, if we look, we can put both of those over 30. So we've still got 7 over 30. And we just double this one to go over 30, and double 14 is 28. And this one was take away. So we can simply take away 28, take away 7 is 21. Our bottom isn't changing because it's still out of 30 as the total. One thing we've got now, so the answer is 21 out of 30. One thing we can know there is 3 goes into both of those numbers. So we can actually simplify that answer down. 3 goes into 21 7 times, and 3 goes into 30 10 times. Can't simplify down from 7/10. So that calculation, the actual answer would be 7 over 10. So we found again a common denominator in 30. We've got our answer, but then we've actually simplified it down as we talked about. So as I say, I won't go through this slide. This slide basically just shows an example of what I've just done, but just so you've got a record when we look at the slides afterwards. The key things, you need the same denominator, known as the common denominator. Again, a bit of a mouthful, and you don't necessarily need to worry about the term. It basically means the bottom has to be the same before you can add or subtract. Then all you do is add or subtract the top numbers, keep the bottom number the same. Make sure you don't forget to simplify your answer as well. Slightly more straightforward is multiplication. He says, if you can describe multiplying fractions as straightforward. Again, if you think of a straightforward example, we'll just say 3/4 multiplied by 2/3. And with fractions, so with multiplying, we don't need to worry about our denominators being the same. All we simply do for multiplying is we multiply the top line and multiply the bottom line. So 3 times 2 is 6, and 4 times 3 is 12. Remember, in the test, you can have a calculator, or you can have pen and paper if you want to work it out there. There are some questions where you can't have a calculator for. One thing I'll say about 6/12, 6 goes into 6 once, and it goes into 12 twice. So 6/12 is the same as a half. So whenever we're multiplying fractions, all we do is multiply the top line and multiply the bottom line. One extra slight thing to mention here, and this would be the same for addition or addition subtraction, but I'll use it in multiplication, is if we've got these mixed fractions. So what if we had 1.5 times 2 1/5? There's a couple of ways to do this. The easiest way, though, and we just said if you've got fractions to multiply, it's quite straightforward. You just multiply the top line, multiply the bottom. So let's make them just into single fractions. So 1.5 is going to be the same as 3/2. Think about when we were talking about improper fractions earlier. Whole one, this whole one here is worth 2, and we've got an extra half, so it's 3 halves, times 2/1/5, or 2 lots of fifths would be 10, and the extra one there would give us 11/5. So I've jumped through a stage there, but hopefully it makes sense, is that we've taken that whole number and just made it into improper fractions. We can now simply multiply the top line. 3 by 11 is 33. Multiply the bottom line. 2/5 is 10. And actually what we can do with that is we've now still got an improper fraction, so we can split it back down. 33/10 is actually 3 whole ones and an extra 3/10. So our answer is 3 3/10. As I say, there is another way to do that calculation, and it's the same for addition and subtraction. There is another way to do it, but if you make them the whole numbers you've got here into improper fractions, it's a lot easier to deal with than the bottom. So when I was saying before we'd go from improper fractions to proper ones, actually we're doing the opposite here to get there. So a little bit more complicated that, and again I will send you some things afterwards that'll some questions for you to have a go. But the key thing with multiplying fractions is you simply multiply the top number, the numerators, then multiply the denominators. The key thing to look out for is for improper fractions, and always simplifying your answer as we've done there. So quite key. Final thing I want to go through with you is looking at fractions of a number. These are probably the more common type of questions. So the things I've gone through so far have been about using fractions and manipulating fractions. When it comes to functional skills, as you probably all know, the whole reason for it being called functional skills is everyday functioning. And when we use fractions in everyday, it's more like the examples I'm going to give you here, where you're trying to find a fraction of a number. And again, what I'll do is I'll go through a couple of examples and then hopefully can show my working as we do the examples, and that makes sense. So perfectly topical when we've just done Easter, I'm going to talk about Christmas jumper. So a Christmas jumper is on sale and has a third off. The original price was £45, so we want to know how much the jumper costs now. One of the things you've got here is you've got some words in there as well. It isn't just a pure math saying 2/3 times 3/4. There's some words we have to read. So Christmas jumper is on sale as a third off. The original price was £45. So we go back to my whiteboard. So what we're basically working out is a third off £45. I'm very good at pound symbol on there. Yeah, I was going to say £45. So we want to work out a third off £45. And we know that a third is just something split into 3. So out of 3 means split it into 3. And we only want 1/3 here. We only want one of them. So all we simply need to do for this one is 45 divided by 3. Remember, for most questions, you can use a calculator. And I can tell you that 45 divided by 3 is 15. So we wanted a third of this whole number. So all we simply do is divide it by 3. If we wanted a sixth, we divide it by 6. If we want 100, we divide it by 100. Here we want a third, so we simply divide it by 3. The key thing here is this £15 is our discount. It said the jumper was third off and the original price was £45. So our discount is £15. The question, however, said how much is the jumper worth now? So we need to remember to finally do the original price, take away the discount, which equals £30. So often with that, people will work out what the discount is and will leave £50 and put £15 as the answer. And although you've done the maths right, that's not what the question was asking. If the question said £45 jumper with a third off. What is the discount? The answer is 15. But in this case, our question actually said, how much is the jumper now? So we need to make sure we do that extra calculation of giving 45 minus 15, which gives us an answer of £30. Or it could have been another similar example is where there's an increase. There's been VAT is added at 15%, sorry, a third or a certain fraction. How much is it? So then obviously you would add that amount on. In this case, it's a third off. So we're taking the third that we worked out, which is 15, and we're taking that off £30, taking that off the £45 to give us £30 for the total cost. Remember, again, in functional skills, you do get marks for your working out. So if you didn't do that last stage, you may still get some marks for it. But always go back to the question, have I answered it? Christmas jumper is sale, third off, visual price £45. I've done that. How much does the jumper cost now? Okay, well, it's clearly asking me what I want. And if I work through another example of this, so there's a recipe, a bit more detail to this one. There's a recipe for cookies that says you need 500 grams of sugar to make them. But the full recipe makes 16 cakes and you only want 12 cakes for some unknown reason. They're usually better at giving a scenario than I am. So we want to know how much sugar you need. So again, let's have a look at the whiteboard. Okay, so the example said there were 500 grams of sugar, but that's to make 16 cakes. And we only want to make 12 cakes. So our fraction is actually 12 out of, or 12 over 16. If you think back to when we were simplifying fractions before, that is actually the same as 3 over 4, 3/4. So if you think how there's 3 4s going to 12 and 4 4s going to 16. So actually, rather than saying we're making 12 out of 16, we're actually making 3/4 of the recipe. Going back to when we talked about simplifying fractions, 3/4 is a lot easier for us to deal with than it is for 12/16. So I'm just going to rub that out. So we've got 500 grams of sugar in the original. In the original one, and we now want 3/4 of it. Well, if we use what we just did in the last example, if we work out 1/4 of 500 grams, that is simply 500 divided by 4, because we want it in quarters, which means split into 4, and we only want one of them. And I can tell you, and you could use a calculator for this, or fingers and toes, if you can write in it. There we go. So 500 divided by 4 is 125. We said up here that we want 3/4. So hopefully you can see straightforward. If 1/4 is 125 and we want 3/4, we simply multiply that by 3, which gives us an example, an answer of 375 grams. That's what we're talking about. So for this one, there was 2 stages we did. First of all, we had to work out, it was 12/16 we wanted. Well, actually, that's the same as 3/4. So the first thing we've done is simplified our fraction. We then said, if we want 3/4, and again, there are different ways of doing this, but I would suggest the easiest way to do this is let's work out what 1/4 is. And that's fairly straightforward because it's just divided by 4. It's just dividing it by 4. And once we've got our figure for 1/4, 125, if we want 3/4, we just multiply it by 3, which gives us an answer of 375.
Can I just add, Paul?
Yeah, go on.
With you mentioning showing you're working out, can I please stress, even if the answer isn't correct in your exam, as long as you've shown you're working out, you still get marked for that. So you've shown a method in your exam.
Spot on. Something like this would normally be, and say I've come up with the example, but normally let's say it's a 3-mark question. You'd have 1 mark for recognising 12 out of 16 is the same as 3/4. Another mark probably for working out that 1/4 is 125, and then your final mark for multiplying that by 3.
Yeah.
What sometimes people often do, and with they do it more with percentage actually, but you can do it with fractions, is use the calculator. And whilst the calculator is very, very good, you need to know what you're doing on the calculator. And if you just type in some numbers and hope you get the right answer, you may have done, but you may not. And by just using the calculator on this, you wouldn't show those stages of 12 over 16, a bit like I did on the screen. I've got rid of it now. 12 over 16 equals 3 over 4. So there's 1 mark, and I've shown that I've got that 1 mark. 500 divided by 4 is 125. So there's my second mark. And then multiplying that by 3 gives me 375. So I've got 3 clear stages. So if I've made a bit of a mistake, and actually when I did 500 divided by 4, I typed in 505 by mistake and got my answer wrong, you're still going to get marks for your working, even though your answer were wrong, because you've done the right things. You've just not quite got the right answer. So in that case, you'd get, say, 2 out of 3. So Eamon's absolutely spot on. The more working you can show, the better.
Yeah,
I appreciate you have a time limit for your tests, and I appreciate that can be difficult, and it is about getting the right answers. I do appreciate that. But that an extra 1 or 2 marks when you've made a simple mistake on a calculator, if you don't show your working, the answer would be wrong, you get no marks. You show your work and you make a slight mistake, you might still get 1 or 2 marks. That could make all the difference between passing and not passing. So yeah, really good point, Aidan. Okay, so quite a bit that we've gone through, and say I'm hoping some of it you watched and thought, well, that's really obvious, and maybe some of it you watched and thought that's a bit, I'm a bit unsure about that. I'll need to practice that. And that's the point of recording this, is that you can go away and practice it and have a look, and I will send you practice questions as well. But I've gone through fractions and think about the numerators on top, denominator at the bottom. As I've said a few times, the numbers aren't, the names aren't that important, but it's recognizing how it's structured. Improper fractions are simply fractions that has a higher number on the top, and if that's the case, you want to turn them into whole numbers. To simplify fractions, you're trying to reduce the fraction down to the smallest possible number that you can. So rather than having 180 out of 300, you're reducing it down to an easier number to deal with. Comparing, adding, subtraction, and multiplying fractions are all related. One of the main things, comparing, adding, and subtraction, you have to have the same denominator, the same number at the bottom of the fraction. So they're key. Before you can do anything else with each of those, you need to have that. Multiplying is a little bit more straightforward because you simply multiply the top line and multiply the bottom line, but look out, as I said, for improper fractions. And then finally, probably the most common type of question is you find a fraction of an amount. If you're finding a third, a quarter, a fifth, whatever, you simply divide by that number. If you want, for example, as we did there, 3/4, the easiest way to do it is go down to find out what was 1/4 and then multiply it by 3. If you need 7/9, divide it by 9, so you've got 1/9 and then multiply it by 7. Once you've gone down to one fraction, it's much easier to go up instead. Thanks very much for listening. I am going to stay around for any questions if you have got any, but I do appreciate your time today, and I will send you some things out afterwards with some questions. Thanks very much for listening.